Welcome to Part 1 of the Distech Controls ECC-VAV and ECC-VVT tutorial series. The tutorials explain how to configure the controllers and provide an overview of how these controllers can be used with the EC Smart Sensor and wireless sensors. Please note that during this tutorial, I will often refer to the ECC-VAV and ECC-VVT product line by using the generic term VAV. Please make sure to plug in your speakers and turn up the volume. You can press F11 to get a better view of this window at any time. The ECC-VAV product line features 4 universal inputs, 6 hardware outputs, and 6 network outputs. The hardware outputs and network outputs can be combined to control up to 8 pieces of equipment, including lighting. The VAV can also perform two-room control. For example, it can independently control the baseboard and lighting in 2 rooms based on the needs of each room's occupants. It will also optimize the use of a single VAV box between the 2 rooms. All equipment outputs can be overridden using network overrides. The VAV's pressure sensor is zero calibrated at the factory, reducing the time you need to perform air balancing. The VAV features a new brushless motor by Bellomo for increased reliability and accuracy. The ECC-VAV product line supports the EC Smart Sensor, which is a digital sensor with an LCD display. The Smart Sensor can be used to balance the associated VAV by accessing a password-protected administrator mode. Distech Controls offers VAV and VVT controllers with integrated wireless receivers that support a full suite of wireless sensors and wireless light switches. Now let's take a look at the VAV configuration plugin. This tutorial assumes that you have already installed and registered the ECC-VAV plugin and have created a VAV in your network database. We will begin with the sensor input screen of the configuration plugin. This screen is split into the Hardware Input tab and the Smart Sensor and Wireless tab. We will discuss Smart Sensor and Wireless configuration in a subsequent tutorial. Please note that you can click on the Help button in any screen to bring up detailed context-sensitive information. Let's set up some typical inputs. We will begin by adding a space temperature sensor. In the pop-up, we can confirm that we want to stick with the default values. Let's also add a discharge temperature sensor and a set point adjustment. We can click on the Configure button to customize a number of options for each hardware input. We are now looking at hardware input 3, which is a set point input for room 1. Let's set the default value to something logical like 22 degrees. The network variable will be forced to the default value if the hardware input object is in the disabled state or if the input reading is invalid due to an electrical fault or a severed connection. Let's also limit the range of the set point input to between 20 and 24 degrees. We can set the max value to 24 and the min value to 22. If we adjust the set point potentiometer and click on Get Value, we can get an updated value on the screen. This window also allows you to access the Change Type window. The Change Network Variable Type window is typically used when you need to modify the variable type before creating a binding. Now let's proceed to the Equipment Control window. This window replaces the hardware output window that we used to have in the previous generation EC-VAV-L controller. The ECC-VAV and ECC-VVT product line can control up to 8 pieces of equipment using a mixture of hardware outputs and network outputs. The network outputs can be bound to the physical outputs of other controllers. This means that the VAV can be used to control equipment that is physically wired to the free hardware outputs of some other controller on the network. There are a number of configuration steps that must be completed in order to control equipment using the VAV controller. We will learn about equipment control by configuring local two-stage duct heating, perimeter heating controlled with a floating valve, and network lighting. Our equipment will be set up based on the following parameters. The first heating stage is connected to digital output 1 of the VAV. The second heating stage is connected to digital output 2 of the VAV. The heating stages should be off for at least 5 minutes before they turn back on. The perimeter heating is controlled using a floating valve that is connected to digital outputs 3 and 4. If the VAV is put into override, then the heating demand should be forced to 50% and the lighting should be forced to on. The lighting that is being controlled is not connected to any of the physical outputs of the VAV. The lighting relay is actually connected to the output of some other controller on the network, but it is being controlled by this VAV. Now let's configure the equipment as per our example. Select duct heating from the first equipment type drop-down menu. The control properties window will automatically open. Select standard stages from the control type drop-down menu. When you do this, you will see a number of new options appear on the screen. Select the Use Local Hardware Only radio button. Select Hardware 1 from the Stage 1 drop-down menu. The output configuration window will automatically open. Click on OK to confirm the default settings. As we are setting up a two-stage duct heater, we must select Hardware 2 from the second drop-down menu. The output configuration window will again open automatically. We can click on OK. In our example, we specified that the heating stages should be off for at least 5 minutes before they turn back on. So we must set the minimum off time to 5 minutes to fulfill this requirement. Click on the OK button to exit the Control Properties window. In our example, we want to force a 50% demand when the override is enabled. To set up this override condition, click on the Override button that corresponds to the duct heating that we have just set up. In the Override pop-up window, check the Permit option. Then in the Stages drop-down menu, select Only One On. Forcing one of the two stages to be on when the override is active is equivalent to forcing a 50% demand. Click on the OK button to return to the Equipment Control window. Select Perim Heat Room 1 from the second equipment type drop-down menu. The Control Properties window for the perimeter heating will automatically open. Please recall that in our example, the perimeter heating is controlled by a floating valve, so we will set the control type to the floating actuator type. Select the Use Local Hardware Only option. For this example, let us assume that our floating actuator expects digital control signals. Under Selections, we will set the Close Output to Hardware 3 and set the Open Output to Hardware 4. We can click on OK to save our changes and return to the Equipment Control window. Now we will add the network lighting, which was the last equipment type in our example. Select Light Room 1 from the third equipment type drop-down menu. The Control Properties window for Light Room 1 will automatically open. Since we are controlling network lighting, select the Use Network Output Only radio button. Set the minimum on time and the minimum off time to 0 seconds to ensure that the lighting responds immediately whenever a light switch is toggled. Select NVO Control Out 1 from the On-Off drop-down menu. The NVO Control Out will be bound to a free physical input of one of the other controllers on the network. This binding will allow the VAV to control the lighting remotely. The output configuration window is used to specify the heartbeat and throttle for an NVO. Since lighting is event-driven, change the heartbeat and throttle to 0 seconds. In addition to NVO Control Out 1 and NVO Control Out 2, the VAV also has NVO Light 1 and NVO Light 2 that are of the snippet scene type. These network outputs can be conveniently bound to an EC light or any other lawn lighting product. Click on OK to confirm these settings and return back to the equipment control window. Click on Apply to save your equipment settings. This concludes the first ECC-VAV and ECC-VVT tutorial. Please proceed to the next tutorial, which continues with the explanation of the plugin screens.